Hi, this is Chad from Reichhardt Electronic Innovations again, back to walk through the main screen operation of the PSR system using our TAC row feeler sensors. The walkthrough will be very similar to what we did for GPS guidance. There are some unique differences between TAC row guidance and GPS guidance on the main page, and we'll just illustrate those unique changes or those differences. So similar to GPS guidance, we have our banner at the top, our light bar, which will provide some level of deviation measurement, clouds, field, picture of a tractor, information bar, which is going to be very limited with the TAC mode since we don't have existing guidance patterns. Then on the bottom left hand corner we have our sensitivity value, which behaves very similarly to how it does in GPS. We also have a nudge value, which we'll go into a little bit more detail on in regards to row guidance. The icon on the bottom center is our steering mode. You'll see now instead of saying GPS, it says or has a picture of a corn snout with the two paddles and the rows of corn, and this notes that we are in TAC steering mode. On the bottom right hand corner we have the icon that looks like a tractor with an arrow pointing forward showing our driving direction, as well as number 1 for vehicle profile number 1, as well as our current speed, which I'm simulating to my laptop right now. On the right hand side we have our soft keys. The top right icon is our engage button. Same logic as we've discussed in other videos. You have your not engaged. If you press it, you will engage the guidance system. It'll turn green, a solid green if you have speed. And if there are any issues with the system, for example, if we don't have speed or we have an unplugged TAC sensor, it'll turn red. So I'll go ahead and disengage the system. I'm going to unplug the TAC sensor and it'll turn red. If I plug it back in, should have good readings. It'll clear the error and we're back to a tan or a white background like you see here. Below that we have our adjustment for our steering sensitivity as a picture of an axle with a slight angle, and if you press and hold that, it'll start flashing, and now you can hit plus or minus to adjust the sensitivity value here in the bottom left hand corner. The higher the sensitivity, or the higher the reaction is another term we use for this mode or this setting, the more aggressive the system will steer. It can go all the way up to 100, all the way down to 0. The higher the sensitivity or reaction, the more the wheels are allowed to turn, as well as the more response our system will have to any deviation in the TAC sensor input. To set the value, you just hit the flashing icon, and you can do this while the auto steer is engaged as well. So you just engage, see how it's steering in the field. Oh, it's a little bit lazy, for example. You can hit the plus button and just increase the reaction until you find a sweet spot, and then set that value. The next icon down is our nudge setting, and to adjust the nudge value you just tap this icon, and now you'll see right and left arrow keys, and you can hit right or left, and it'll go right or left on this value in the bottom left hand corner. One important thing to note is that this value is not a numerical measurement. So when it says minus 7.9, it's not moving you 7.9 inches or centimeters to the left. It is shifting our system an increment in terms of our calculations. So depending on your working with and how our system's set up, maybe a minus 7.9, it may only move you an inch or less than an inch in some cases. So the best way to figure out what the value is for this would be to have the system engaged, and then from here you could adjust this value, and you're going to adjust this until you're centered in the row. If everything's balanced and we have a good angle sensor calibration with the system, everything is set up good with our tilt sensor calibration, the sensor's mounted properly in the center of the corn snout, typically this nudge value is going to be set to 0, but this allows a quick adjustment to compensate for those things. So to do that, you would engage the auto steer. Let's say I'm hugging to the right side of the row a little bit. You just incrementally hit the left arrow until the machine actually steers in the center of the row. The next icon down is the wrench icon. This is where we can access our configuration menu. And to access the configuration menu, we need to make sure that we're in the TAC steering mode. To change our TAC steering mode, we need to select the icon in the bottom right hand corner, and after that it'll move up a few spots, start flashing, and below that you'll have some buttons. Either they're going to be right and left arrows, or if you're running an older software, maybe a plus or a minus. But when you press this, it will change your steering mode in the bottom center, and you'll want to just make sure that you are set for row guidance, which is the corn snout icon, TAC row guidance specifically. And then once you selected that, just press the flashing icon and that'll lock you into TAC steering mode. Once you're in TAC steering mode, you can then press the wrench icon to go to our TAC configuration page. When the auto steers engage in TAC steering mode, with the single sensor here at my desk, if I press in on the right side of the sensor, it'll think it's closer to the right, the tractor will move to the right, and the light bar shows that we need to go left, and that's an accurate representation of what we need to do with the system. If I release this, eventually the system will stabilize and go back to a center position. And vice versa, if I press it on the left side of the sensor, it'll start to hug to the left side, showing arrows pointing to the right, noting that we need to steer to the right. Even during normal operation, just be aware that sometimes the system may track perfectly down between the rows, yet you may have an offset in your light bar, or something looks a little off or non-centered. Go back and just make sure that the machine's tracking where it needs to be. Don't be so focused on the light bar. Often when there's a nudge put into the system, or if we have a unbalanced angle sensor calibration, things like those can affect the light bar display. And your ultimate reference is going to be where is your corn snout or where are your booms with respect to the crop. To access the TAC configuration page on the home screen, you'll need to be in TAC steering mode, shown by the icon in the bottom center. You'll need to tap the wrench soft key on the right hand side. And from the TAC configuration page, you can see your TAC sensor readings. You can change your input configuration if you have more than one TAC sensor hooked up. You can calibrate the TAC sensor for neutral position. You can access advanced settings, as well as you can change your TAC input mode, and we'll review all these in a little bit more detail. To start at the top, you have your readings of TAC 1, TAC 2. Those would represent the left and right hand side of your single TAC sensor. If you have a second TAC sensor installed, you could also have readings for TAC 3 and TAC 4. The top row of values are the current values being output by the sensor. The bottom row of values are the last calibrated values. The default calibration values are 50. Over time, the TAC sensors themselves can have a natural curl to them. And when this happens, the neutral values will go up maybe 5, 10, 15 counts from the original of 50. So for example, at my desk I have a TAC sensor hooked up. I'm going to go ahead and just press in a little bit on the sensors. Now you can see we have 57, 58, 53. If I hit calibrate, it takes those top numbers and sets them to the new bottom numbers. And from here you would hit the OK button and it will store that change. So if I go back into that menu, you'll now see the bottom values, 57, 53 are stored. And all that does then is with our system, it will not react until we get to a value higher than that 57 and higher than that 53, plus an additional filter or threshold in our system. Changing these calibration values will help our system determine when we are in corn and not in corn. So when we're not in corn, we know when to not utilize the sensor. To touch a little bit further on TAC 1, 2, 3, and 4, I'm going to pull up an illustration. Shows all 4 inputs. When we use 4 TAC inputs, we actually are using 2 sensors, each with 2 unique inputs. So you can see here in the picture we have TAC 1, TAC 2, TAC 3, and TAC 4. This would be on a self-propelled sprayer with 2 TAC sensors installed, a left sensor and a right sensor with view with respect to the operator. And then on the left and right hand side of those sensors we count up 1, 2, 3, 4. In a combine we would have just the 1 sensor and we'd have TAC 1 and TAC 2. On a combine, you'll see here, view from the front of the combine, we have TAC 1, TAC 2 in a single TAC sensor. And that's what I have set up at my desk as well. On the TAC configuration page, right now we have the icon showing a single snout with a single sensor with two inputs, a TAC 1 and a TAC 2. If I select this, you can see the different patterns. So the next icon over would be for two sensors. If I select that, you'll notice that I don't have a second sensor wired up. So you have values of 0 and 0. And if I try to run with this, I would actually get error codes in our system. We also have unique configurations depending on different patterns. A good example would be this one shown right here. We use this for markets like cotton, or if we have extra wide rows, 36-inch wide rows, we may put two TAC sensors in a single corn snout, reading the outside sensor from each. So then we're reading TAC 1 and TAC 4. And then for applications like seed corn, sweet corn, often we have situations where we want to read only a left sensor or a right sensor in a two-sensor system. And this allows us to read the left sensor or the right. You'll notice that the left sensor would be the same as a single sensor. Also to note, if you do pick a different configuration in newer software, in the main screen, it'll actually visually represent that in the steering mode icon menu. It gives you a quick reference to show which mode we're in. And to change it again, you would go to the TAC configuration page, select your mode, and hit OK. Also to note, the calibration button would apply to that specific configuration. So if I have 4 sensors and I hit calibrate, it calibrates all 4. If I'm in 2 sensors and I hit calibrate, it will only calibrate these 2, and this will not be affected in our memory. Below the calibrate icon, we have a button that says Advanced Settings. If I click on that, it'll take us to our second page of TAC configuration. I call it our Advanced Settings TAC configuration page, and you'll see a couple of sliders. The top slider is our TAC Response, and for most harvesters you're going to have a value somewhere in that 50 to 75% range, and this is something that can be adjusted by the operator, and it goes hand in hand with the main screen sensitivity or reaction, but this is something that the operator can go in and adjust to make the system more responsive to deviation or readings from the TAC sensors from neutral. And to change this value, you just hit the plus or minus button. My suggestion would be to take it, adjust it by maybe 5% of the time at most. And then to save that change, you would hit the OK button, and then you would hit the OK button again. And you should see an immediate impact in how the system is steered. If for some reason you need to go back to your original default settings, go back to the advanced settings and you can select default, and it'll put it back to the default setting per the vehicle code. Below TAC Response we have Gyro Stabilization. Gyro Stabilization for combines is typically left at 0. For sprayers it can vary significantly. I've seen it with values as low as 0% all the way up to 40%. And you can adjust that by hitting plus or minus. You see it'll stop up at 40. Since we're steering a combine, we're going to leave this at 0. If you have an older solution that has an LT controller, silver box, and a gyro, or would require an external gyro but no gyros installed, this would not be applicable. You would need to make sure that this was left at 0 or you'll have a gyro error code. It'll be looking for a reading from a sensor that doesn't exist. With our MC controller, this is already embedded, but it's critical that our TAC MC or our MC controller mounting orientation is correct per the install instructions. Again though, for a combine, leave this at 0. For sprayers, this can be used especially on front boom sprayers to stabilize the system, but be wary that if you set this value too high, there may be more emphasis on stabilizing the machine rather than guiding to follow the rows, and may make the system too lazy. Below the gyro stabilization, we have tilt correction of the axis. You'll see below that it says roll angle and a percentage value. If you have a Reichhardt installed and calibrated external tilt sensor with our LT controller, or an MC with a calibrated tilt sensor, you can go in here and increase this value. And what it does is nudges the system left or right based on feedback from the roll angle sensor. You can put in a value anywhere from 0 to 100%, and it scales the influence by that. So if I put any kind of a non-zero value, for example 25%, it also gives the option for a pitch angle if you're using the MC controller. And what the pitch angle does is scales the amount of roll angle compensation based on if you're going up a hill or down a hill. So pitch would then scale roll, which then shifts our system left or right. There are some adjustability to this. It really depends on the scenario and the type of chassis or type of machine that we're operating with, which may affect a need to have a roll angle. If there's a specific profile for, say, a certain model sprayer or combine that would benefit from this, typically these values are defaulted to what is recommended based off of our experience running those machines. To save the changes, just simply press the OK button, and then you'd press OK again, take you back to the main screen. Below Advanced Settings, we have Mode. And from here you can select 3 different modes within the TAC Steering Mode. And this allows us to steer based on the pattern and if we want to incorporate GPS with our system. So the default or the most common mode that we use is straight, and what that is designed for is following straight rows of corn or straight rows of crop with our TAC sensor. It does not adapt to any kinds of curves or follow any kind of a strong deviation other than a straight line. It does not incorporate GPS. It is the tried and true classic TAC mode that we've had with our system dating back to the mid-2000s. And for that reason we keep this in here, and this is the most common mode that we run with for most applications. Below straight we have curves mode, and you'll notice if you switch to curves mode, just to notify here on the main screen, if you switch, press OK, you'll now see on the main screen here it says curves. And what curves mode allows is more movement of the steering axle to follow things like pivots, or if you're harvesting in terraces where you have strong curves, it'll allow the axle to turn stronger and maintain a quote-unquote center position that's not true center of the axle, but at an angle to maintain a curve pattern. Curves is great in certain scenarios. However, if you're running in a known straight mode, we recommend running in straight. So if you're in a straight field, stick with straight. If you want to try out curves, this has a good fit as a really good option for certain field conditions, certain field types, then use curves mode. But it's based on personal preference and what type of field you're going to be running in. So as a quick introduction for Combi mode, you'll see here we have a diagram showing how it basically functions. This is a screenshot pulled from our main operator's manual. And in the example shown here, it shows a tractor, but it's the same concept whether it's a combine or a sprayer or a tractor. But the way the system works, you'll see the black dotted line here. It's guiding off of sensors, and at this point when it's guiding off the sensors, it's actually recording GPS position points in the background. When you disengage the auto steer, that's when you see the blue dash line. When you disengage the auto steer here, it records a point a short distance back from where you disengage, plus a point further back to create an AB line. It takes that AB line and calculates a distance X perpendicular to that AB line for the next pass. While you steer disengaged around to the next pass, when you get to the halfway point between your original pass and your next pass, this system will automatically change to a GPS steering mode. When it changes to GPS steering, you can engage the auto steer and it'll GPS steer into the next row. Once it has steered and maintains a GPS guidance line, or steers to the GPS guidance line with minimal deviation parallel to the line, it'll then automatically switch back to row guidance. So it'll automatically GPS steer you into the next pass. Once it's on the pass, it'll switch to row sensors, and then it'll proceed to guide with row sensors. Same process as before. When you disengage again, it'll then create another new AB line and calculate X distance over for the next pass. What it doesn't do is store your AB line in memory forever. It also does not store it for more than a period of time. So if you park the machine, you say you're going to go dump corn or go fill your sprayer, it will lose that AB line. You'll have to find your reference point again. And so it's limited in how it's used, but when it is used, it can be a helpful tool depending on the scenario. And again, it's only limited to straight rows. So when you select Combi mode in our system, for an example here, we selected a width of 22 feet. I'm going to go ahead and use Combi mode at 22 feet, press the OK button. And right now I have a simulation running on my laptop. We are traveling due north, 0 degree heading. I'm going to go ahead and engage the auto steer. And we're going to start tracking as if we're in a cornfield with sensors. Right now the PSR system in the background is recording our A point / B point. When we disengage, it'll create that AB line. From here, I'm going to proceed to turn to the right in my simulator. So I'm turning 90 degrees, and now I'm heading due east. And you can see now we're actually counting up passes from our original AB line, and we're now in GPS steering mode. I'm going to go ahead and turn right again. Now I'm going to turn south. I'm going to go ahead and engage the auto steer. Let's see if I can get it going here right. Not very good at steering here with my simulator. There we go. And once it's guided GPS on the line over X distance, it'll automatically switch back to TAC row guidance. So as you can see, it stayed engaged and now it's guiding off of sensors. So now that we've traveled another distance, we're going south again. I'm going to go ahead and disengage the auto steer. I'm going to turn east again. And now you can see it's starting to turn. There's a bit of a heavy filter right now because I'm running a simulation. There is no yaw rate detected by our system. That's why it's taking longer for it to turn. So now we're heading east. We're jumping over several passes. There were 6 passes from our original AB from when we created our last TAC mode. I'm going to go ahead and turn due north. I'm going to go ahead and engage the auto steer now. Pretend it's auto steering into your row. And automatically switches. So as we mentioned earlier, Combi mode, it's a nice feature. It has limitations in the fact that it doesn't store the line over a certain period of time. It doesn't store independent of power cycle. These are modes that we've had some internal discussions about adding some additional features to, but currently as is, it'll just guide you into the next pass based off of a recorded line when you're row guiding. In addition to general operation of the system on the main screen for row guidance as well as the TAC configuration page, I'm going to walk through a few general troubleshooting items with our system. What I'll do is pull up our install or setup guide for row guidance in a combine. And if we scroll down here, there's going to be a few sections I'd like to touch on. This is a newer revision document from, I believe, this February 2019. So one thing to note here is just the general assembly of the sensor. These are common pitfalls we've run into on just when we do service calls, things like that, just things to take a look at. The first thing to note here, it says here TAC Sensor Assembly and the mounting plate. There's a TAC Paddle component and then the main sensor component. And there actually is a right side up and an upside down orientation of the paddle. We need to make sure that it is consistent. So if it's a full length paddle, on the inside of the paddle there's actual nub sticking out of the paddle, and in the TAC sensor itself there's an indentation. We need to make sure we line up the nub with the indentation. Otherwise the paddle would be upside down and the magnets which are in the paddle may not align properly with the TAC sensor. It may seem to function. If I show you, for example, here in our system, and on our TAC configuration page, you'll notice right now we have our TAC sensors, TAC 1, TAC 2. If we had our paddle mounted upside down, I'm going to press these sensors in all the way. Right now we have readings of about 450. When I'm all the way at neutral, has a reading of about 50. If the paddle's not lined up perfectly, we may have a neutral reading of 50, but when I press all the way in with the sensor, it may only go up to 280, 300, 350. It actually limits the physical output of the sensor. And in the case of, for example, 30-inch row spacing, you can have a very limited range in the readings of the TAC sensor. And that's why it's really important. It may not kick out an error code. It's just going to limit the output range of the sensor. It may also eliminate some of the symmetry between the left side and the right side as well, depending on how it's pushed into the sensor. So that's why that alignment's really critical for performance. So just to note here on the readings, normal behavior, neutral, if there is no magnet detected, it should be 50. That represents 1/2 of a volt. If it is pressed all the way into the sensor, you should go all the way up to 450 for left and right, and that would be 4.5 volts. And that would be the full range of a TAC sensor. It's not your normal operation range, but that would be the full output range. Looking a little bit further down, on the front edge of the TAC sensor, we have a front plate. You'll notice right here that the plate actually tapers away from the sensor. And the reason why is this allows full range of motion, and the paddles are flexible. They can have a flopping motion, and this avoids creating any kind of a pinch point between the metal plate and the paddle. It can also create a wear point. In many cases, we've run into machines where this paddle is actually inverted, turned around, where this tapers inward. Not only does it create a wear point, but it actually pushes the paddle in enough where our neutral value now can change to something like maybe 60, 70, 80, up to 100 counts we've seen. And what I can tell you right away is if you have a neutral reading of, say, 100 counts at rest, and then you get into 30-inch corn rows, even when you're pressed up against the corn, maybe it only goes up to 150 or 160. Well, at that point, you really don't have a lot of resolution with the system. So this can greatly negatively impact the performance of the system. In addition, just to note, if this paddle is mounted in a way where it comes in constant contact with corn, and depending on the age of the plate, maybe it's made of a less robust material, this may have a natural bend to it. Be aware that if it does have a bend to it, we can either replace it with some thicker stainless steel plates, or you may want to spend some time just bending those plates back in place. We want to make sure that when in neutral, not in corn, that this sensor has every opportunity to go back to a neutral position and not be held up by the flat front metal plate protecting the paddle. Another important note is you see right here at the top of the TAC sensor we have a label with our company name on it. You want to make sure that this label is facing upright with our system. If this label is not facing upright, TAC 1 and TAC 2 have now become TAC 2 and TAC 1, and your signals will become inverted. Real quick way to check that would be to go into diagnostics, and in diagnostics just make sure that when you're in here, have someone up front go press in on the left side of the TAC sensor, make sure the TAC 1 value goes up. Then go over to TAC 2, press in on the right sensor or the right side of the sensor, make sure TAC 2 goes up. If you press in on the left sensor and TAC 2 goes up, and you press in on the right side of the sensor and TAC 1 goes up, your sensor's upside down. That or something's wrong with the wiring. But we need to make sure that left is left and right is right. TAC 1 is left and TAC 2 is right. If this is backwards, you will not have any chance of getting proper performance with the system. Another point to bring up is the physical wiring of our system. In this diagram, you can see our TAC sensor and paddle and harness here. This is representing an extension harness. With our kits, we either provide one of two different part number extensions. It's either 702329 or 702344. They are the same general harness, just different lengths. The 329 is about 16 foot long or 5 meters. The 702344 is a 10 foot or a 3 meter long harness. And these are direct wire extensions. There are all 6 wires populated from point A to point B. Note though that the TAC sensor itself only uses 4 of the wires. The other 2, while are populated, should not be wired to anything, should be left open at the end of this harness, wherever it goes to. Pin 1 is power to our sensor, which is going to be between 10 and 30 volts. Pin 3 is a ground. Pin 4 would be the left signal, or TAC 1 in this case. And then pin 6 would be the right signal, and that would be TAC 2 in this case. Left signal, right signal go from half to 4.5 volts, or as we mentioned earlier, 50 counts to 450 counts with our controller. From here, you're going to have one of several different adapter harnesses to go to the main Reichhardt harnessing. In the case of our universal harnessing, we have a single harness, part number 702917. It goes from a standard TAC wiring to what we call our front plug adapter, labeled XO1 on most of our universal harnesses or most of our system harnesses. And XO1 can support not only the TAC sensor, but sonic sensors and our mechanical roll finder. So it's a really versatile connection point. We simply then adapt that to a TAC sensor. If you have a two TAC sensor system, you can actually have XO1 then with a different harness. It goes to 2 different TAC drops, and then extensions run out to the left TAC sensor and the right TAC sensor. So same situation here. Now we have our same XO1 connector, a different adapter in this case, and then we have XO1 and XO2, 6-pin Deutsch connectors, left TAC sensor and right TAC sensor. A couple more points on the TAC sensor itself. This is a bit of a review, but just touching on some of the main troubleshooting questions. First question, what are the normal readings for a TAC sensor? As we discussed earlier, they can range from 50 to 450 counts. So you can see here again, by pressing on the left side all the way up to the sensor. If it's properly mounted upright, the nubs line up on the sensor and paddle, press all the way in, it should go up to 450. Same for the right side. So left side, right side, 50 to 450. And then it does touch a little bit more on what normal reading ranges would be. So if you're in a 20-inch row spacing in the center of the row, you're going to see readings around 130, 140 counts. As you get closer to one side or the other, that value will go up, and the side that's further away from the crop, that value would go down. 30-inch rows, it's not that, it's a little bit lower. You're a little bit further from the crop on both sides. Now you're 15 inches from the corn, from the center of the TAC sensor. Now you have a reading around 90 to 100 until you get closer to the crop. So by examining the TAC sensor readings, if you're troubleshooting performance, sometimes you can get readings that are considered acceptable readings, but mechanical limitations, an upside down paddle, or a bent front plate, these can all affect performance. In this section, it also reviews and again addresses how the readings can go from maybe a max value of 450 counts, now down to 250 if the paddle's upside down. Other mechanical items to note, good reference points, but upside down paddle, front plate mounted backwards as we discussed, the front plate being worn or curved, replacing with our thick stainless steel front plate. It's also important to note that when mounting the TAC sensor, we want to make sure that there's enough opening to allow full range of motion of the TAC paddle. It shouldn't be rubbing up against the corn snout above the paddle, or it shouldn't be hitting the corn snout behind the TAC sensor. We need to make sure that it can fully move and is not impeded by anything mechanical. Another point of emphasis is just verifying that there's no debris between the TAC sensor and the TAC paddle. And that can happen depending on the mounting apparatus, and if there's a lot of debris, it can sometimes get stuck up between the paddle and sensor. It's just a general checkpoint, general maintenance point to observe. Make sure that there's nothing getting trapped in there. Another common question is when we're in narrower row spacing than 30-inch, the TAC paddle is actually closer to the neighboring snout than the full length of the sensor and can actually hang out right on the adjacent sensor. Some installers will trim the TAC paddle off. My personal recommendation is to leave it untrimmed and just let it rest against the adjacent snouts and calibrate for neutral in that position. This allows the paddle to be at full length and actually come in contact with more than one corn stalk. It has less of a ratcheting effect where you have a smoother reading and the paddle seems to just glide between the corn snouts. The last section is my TAC sensor oriented correctly. As we discussed earlier, we want to make sure that TAC 1 is the left side, TAC 2 is the right side, and that can be verified in our TAC configuration page, just verifying that when you press in on the left side, the TAC 1 value goes up. When you press in on the right side, the TAC 2 value goes up. If not, verify your sensor's right side up and make proper corrective actions. If you have any other questions regarding Reichhardt products, be sure to reach out to us. Email us either at info@reichhardt.com or come visit our website and go ahead and click on the links and you'll be able to get in contact with us, or message us directly here on our YouTube page. Thank you for listening.